All right, so another problem that was in that same idea with derivatives and with the chain rule is talking about even functions and odd functions. And just to clarify our terms, an even function means that when you plug in a negative value, it's the same as when you plug in a positive value. And it's called even because whatever is happening on the left side of zero is the same as what's happening on the right side of zero. So all of the values on the left, where the x's are negative, match up with the values of on the right, where the x's are positive. Of course, the definition doesn't actually say the left side equals the right side. It says that any reflection across the y-axis matches up, because technically x is neither negative nor positive nor zero. But visually, it just means the left side equals the right side. An odd function on the other side, on the other hand, means that a negative input is the negative of an output. So that's going to look like this, where if this is a certain point, like negative a, negative b, then it's going to have an image over here that's positive a, positive b. It's a 180-degree rotation. So the question asked us about what happens when you take the derivative of an even function and what happens when you take the derivative of an odd function. So if I take the derivative of an even function, let's use this notation. The derivative of an even function is going to equal f prime of negative x times negative 1, which is negative f prime of negative x. Okay? So what we're trying to show is that this derivative is an odd function. But I know that if I assume this is even, that the original function is equal to f of x. And the derivative of f of x is f prime of x. So what I have is f prime of x equals negative f prime of negative x. Multiplying by negative 1, I see that negative f prime of x is f prime of negative x, which is my odd definition. So the derivative of an even function ends up being an odd function. Very similarly, let me start with an odd function over here. So I'm going to take the derivative of an odd function. I'll just use the letter g here. That's going to equal g prime of negative x times negative 1. But I know that an odd function is equal to negative 1 times its original input. I just move the negative 1 in front of there on the right side. Now the derivative there is just g prime of x. So both sides have a negative 1, and you can divide by negative 1 to get g prime of x equals g prime of negative x, which is an even function. By the way, the terms even and odd come from polynomials and the leading degree, because if you have just the polynomial by itself, like x to the squared with no other further terms, that's an even function, x squared, but x cubed is an odd function, x to the fourth is even, x to the fifth is odd. And so the power, the parity of the power, is where the name for even and odd functions came from.